of the security team in the room? Okay, 6. Okay, got it. All right, this is probably about right. So just remember that count because that kind of works with this. So I see this slide a lot in presentations about describing the relationship between security and engineering, where there's this tug of war. This slide actually isn't very accurate. I don't think this represents the real relationship between security and engineering. I actually think it looks more like this. So, watch this.
Hey, you want I should dig up some bones for you? Anything you say, Spike. Because you and me is pals. That's right, ain't it, Spike? Hey, Spike, you want to play ball? Huh? You want to play ball? Huh, Spike? You want to? Huh, Spike? You want to? Huh? Nah. You wouldn't like that, would you, Spike? Hey, Spike.
Can we pause?
Chase cars,
Can we put
huh?
pause on
Does
there?
that sound like fun?
So here's what's interesting about this is sort of the relationship is I always feel like security team, we're always chasing after development. And we're basically always saying, hey, developers, please code securely, do something, help me figure this out. And engineering is like, whatever, right? Like, move on to the next thing. I got more important things I got to deal with. And this relationship, look, in all seriousness, does exist, right? There's an aspect of where you've got 6 people, people are pointing people, hey, no blames here. But like people are, when you look at security team, we've got 6 people in security team, we've got 80% of the rest of you all in engineering. And ultimately, this relationship exists through various different reasons. But one of the primary reasons is sort of an understanding of security from both sides, as well as some of the things that both security does in the wrong way and engineering needs to do in the right way. So I'm going to walk through that. The first thing I want to show, as you can sort of see in the slide here, is there's a fundamental thing that both sides need to understand, and that is security is a pain in the ass. And I mean that truly deep into my heart. As someone who, by the way, is also a developer, I develop most of my products, it is a pain to understand security. But the thing is that many people on both sides think differently. So for example, on the security side, security people think, well, engineers, why can't you just write secure software? Why can't you just write secure code? Why are there all these vulnerabilities? Why can't you just do this? Here are the things. Let me give you the list of things. There's only 10 bullet lists of things you need to remember. Why don't you just write secure code? And then on the development side, I've also seen the opposite, where I've seen more overconfidence, where I've seen engineers and senior developers be like, well, I know security. I know how to do encryption. I know how to manage access control. I know how to implement authentication. I know I got it. Don't worry about it. Believe me, I know what I'm doing. Like I've seen on both ends of this side of the thing where this has occurred. When in reality, it's actually much more intricate and much more of a pain in the butt than this is. So the best way to describe this is actually by giving you guys sort of an exercise to do this. So this is an actual snippet of code that was pulled off of Microsoft's website. So think of this as an API method that's been exposed. It's an API. This was actually pulled out of Microsoft's documentation. What I want you guys to do is tell me where the vulnerabilities are. All right, what do we got? Go ahead. What? SQL injection. I heard SQL injection, right? That's one. What's that? Not enough resources? Not cleaning up resources. That's a good defect. I would put that in there. Yep, sends password in clear text back to the user. User and password. What else? Validating inputs. What is it? Logging the password. What's that? No salting. Yep, absolutely. No encryption, no salting of the password. There's actually another one. Yeah. Agreed. Is you get the stuff back, absolutely. And there's one more behind you. What were you going to say, Les? Yeah, it does. And then actually there's one other one, which is cross-site scripting, in the fact that, one, no validation of input, two, returning the password back also embeds the aspect that, hey, there could be cross-site scripting in this. Ultimately, you guys name more than this, but there's basically six issues, completely independent types of issues that exist in 6 lines of code. Now, this is an overly bad function, obviously, right? And the fact is that, hey, in most cases, it's not going to be that bad. But what it does demonstrate is the fact that security people, by the way, when I sit in front of a bunch of security people and I ask them to go through this, like, it's tough, right? They don't understand how to read through code. And oh, by the way, developers, knowing and understanding real security impacts when reviewing a piece of code is hard. It is a pain in order to really understand all the impacts. But like you guys, what I really like is you thought like a hacker, right? You start putting on that hat and you start thinking about, hey, what are the ways, given this thing, are there issues? And that's a great thing to think about. Okay, so I kind of did that to establish sort of the basics, which is that there on both ends, we have a good understanding that security is hard. But how do we start melding the relationship? And I'm going to start on the security side. So what's great is, since I'm from security, I can like call out all of our crap. So I'm going to call all that out to you guys here today. We primarily, I would say, make 3 major mistakes. One, we have no knowledge of engineering, because most security people come from an IT background, if you ever notice, guys, which probably creates a gap right there. I'm coming from hosts, routers, and networking, and I'm trying to tell you how to do secure development. 2, we have bad policies and training, which we're going to dig into each of these. And then 3, badly configured security tools in what we do, which is, by the way, all impacting you guys as you're developing. So let's go for the first one. Knowledge of engineering. It is amazing. I would probably say only 2% of the security people that I talk to, when I ask them these questions, know any of the answers. Right? You guys as engineers probably all know these answers. What are my cycles? What's my roadmap? How many projects am I tracking? What's going on? What types of pipelines am I doing? What schedule am I running on? All of these things are things that you know because that's what you do every day. But from a security perspective, almost nobody knows the answer to these questions. And this is one which is a lack of understanding of engineering and the ability to really dig into and know what it is you guys as engineers do every single day. So that's sort of point number 1 that we need to understand, is we've got to get more involved and have a better understanding of engineering. 2, bad policies and training. So this one, I would say 99% of all security people implement. Let's find out if you guys implement the same type of thing. By the way, no offense to the security team, if that is the case. So bad policies and training. The number one thing that I see when I ask them, what are you doing to make secure software? Oh, we train our developers. Oh, okay. What do you train your developers on? And they say, well, we train them how to write secure code. What? In what way? Well, we make sure that they know about the OWASP top 10. Do you guys know what the OWASP top 10 is? Only a few of you. Okay, that's actually pretty good. What do you guys get trained on in order to understand secure coding? Anything? What's that? Ah. So here's what I see in a lot of organizations is they'll say, well, we train on OWASP top 10. And then that's what they basically do is they say, here's a list of these issues, go and figure it out. So I'm going to give an exercise here, but not just to you guys, but also to the security guys in the sort of right over there and in the back of the room. How many of you know what the OWASP top 10 actually is? Who can list it? Anyone? Oh, someone in the back. Did you raise your hand? What's that? Oh, you can do it? It does change yearly. Do you know what it is? This brings up a very good point. And this is my point, especially if I stand in front of security teams and they try to train us, is like, as developers, we don't know what the OWASP top 10 is. Why should we expect any of you guys to know what that is? And by the way, just for reference, this is what it is. right? And this is basically a list of sort of the top 10 yearly issues that OWASP, which is this Open Web Application Security Project, produces to say, here are your problems in writing code. These are the things that you need to know about in order to write secure code. But I can guarantee you that when I'm writing code, these 10 things are the last things that I'm thinking about. Because one, I don't know them, and two, I'm focused on something completely different. And generally, by the time I get to security, it's after I've got something functional, working, and then I'm like, hey, what do I need to do to validate input? Like, that's pretty much the extent of where this comes from. So training on this type of stuff becomes very complex in that we're trying to force this stuff down engineering's throats and it's not getting across. You guys are lucky I didn't try to get you guys to name the SANS 25. I don't even know where that comes from. Okay, so what we decided, well, what's a better way to do this? And actually there's multiple better ways that we've identified in order to do this, is when we talk to you guys as engineers, the first thing that we do is we say, hey, forget long lists of issues. I only want to focus on one, maybe two issues maximum that I want you guys to know about. And I will beat that into your brain ad nauseum. So SQL injection, what is it? How do you recognize it? Here's where you do it. Here's what's going on. I'm going to get me as my teams to sit in front of you guys, talk to you about it. Here's what happens. Hey, by the way, I'm going to let you guys hack a site using SQL injection, right? So you get to understand really what it is. And that's what I want you to do. And so my goal for the next quarter or even the next 6 months is to make sure that SQL injection is the only thing that you think about, or cross-site scripting is the only thing you think about, so that we can eliminate that thing. And when you're coding and when you're developing, you remember it, you understand it, and you can go and you can complete it. This is one method of being very effective. And then as you complete it, I turn the knob a little bit more and I go to the next one. By the end of the year or so, you guys are going to be security experts, you won't even know it, right? It'll all be done slowly in a way that you, as you code, can experience this. There's another way to do this. And that is that, and we've seen this work somewhat successfully, but fairly successfully in large organizations, where instead of me telling you about a vulnerability, what if we say, guys, hey, we need a blessed component that you guys can all use that automatically eradicates, does validation checking. So let's say anytime you guys put in a login form, right? Hey, I need to accept the login or manage credentials. Here are a set of libraries that you guys can use. Security's already blessed it. You don't have to do anything else. You just use the library anytime you're calling that function. That's it, you're done. We don't have to worry about it at all. It's all completely, you don't have to worry about security, you don't have to worry about SQL injection. Whether OWASP changed last year to this year, it doesn't matter to you. You use the blessed component, boom, you're off and running to the races in order to build what you need to build. So this is another great method of being able to do this. What do you guys think, yay or nay? This is a good question. What are the problems with this? Yes, I got some thumbs up. Are there problems with this model? Yes?
Yeah, so once it's broken, all of your applications are broken across the board. So you have one DLL login for all your sites. Once there's vulnerability for that one DLL, then all of your sites are vulnerable and all of them are subject. You could update all of them and put all of them at once, but since there is a vulnerability in that one DLL, all of your sites in DLL are not vulnerable.
Great. Any other? Yeah. You see how it's done right. You can see how a component is done securely, which, by the way, the only way to do this is to involve you guys in it, right? Is security pulls you guys to help build this component, because your code is your code. You're going to know how best to do it. But you can also see how it's done well. There's also another method of being able to do this. Even better, that I found very successfully, especially when it comes to security design and architecture and threat modeling, it's to go to you guys. A lot of times, as a security individual, I don't understand engineering, but I know I've got a problem, right? For example, we have found in our bug bounty programs or our vulnerability assessments that we have all these authentication issues. How do we solve this problem? Can I get you guys in a room and present to you a challenge on basically saying, here's our issue, here's where we're running into the problem, what should we do to solve it? Can you guys come up with something that really helps us figure out how to solve this problem? Which in a lot of times, by the way, turns up into turning into those libraries or components. But it's been pretty interesting seeing some of the innovative ways at which engineers come up with compensating controls to solve a problem that us as security people, we would have never understood or learned. And so I also think this is a great way to get you guys involved and help build some of that relationship. Okay, moving on. Badly configured security tools and process. Now, I don't know what you guys use here, but do you guys use any sort of security code scanning tool or anything that you get results from? Yes, what do you guys use? Veracode and Fortify. Okay. Check marks, you guys use. Oh, so there's a distributed set. Coverity. Wow, so all of you guys kind of use your own choice of tool across your groups. Well, that's really interesting. Wow. What's that? Oh, yeah. Okay, yeah. So there's sort of a set. Okay, so this becomes somewhat relevant. Okay, so when I say security tools and processes, the number one problem that happens when I implement a Fortify, a Coverity, a Veracode into the process is basically this is what ends up coming out of it, which is every developer I've ever talked to goes, oh, that just gives me more crap to do. So you give me a huge to-do list after every one of these scans, and by the way, 70% of them are false positives or aren't relevant to what I'm trying to do in my code today. This is a huge problem for me. Like, you've configured the tool, this tool is wrong. And so now what you start seeing is where us as security, we're trying to make these strides to move forward. Engineering is backing up and they're like, hey. Like, one, I don't like these tools. They're giving me way more work. Like, you don't understand what's going on in engineering. A lot of these things kind of start separating out sort of that relationship. So I want to walk you through a little bit about how at Capital One we tried to help solve some of these problems, all sort of in one shot, right? And we actually did this via a solution that we ended up building. So I'm going to walk you through sort of what we did at Capital One, and maybe that'll give you guys some ideas as whether this will work in your organization as well. So one of the first things is when we look at the sort of the tools and the process and the others, like they're not very CI/CD, they're not very iterative, it takes a long time to do things. So here's sort of what we decided. Our problem statement was this. Let's see if this is familiar to you guys. It could be. But our environment was pure chaos. It truly is pure. Well, Capital One, how many of you know Capital One? We are an innovative company, right? Like, we are known for innovation, and innovation moves at the speed of light. And I got to tell you, I'm from the startup world, and I think Capital One moves fast. And that chaos is actually what helps Capital One move fast, oddly enough. But we have 3,500 different apps, 3,500 different application teams, all running on their own timeline, all running in their own cycle in every language imaginable with no single pipeline to manage any of them. So literally, if I want to get my app teams to write secure code, I have to go to every single one by one, and try to convince them to use the tool and write secure code, or to train them, or to do whatever we could in order to make this happen. Here was our pain points in this. One, if I wanted to get you as a dev team to write secure code to enroll, I've got to email you first, say, hey, here's this thing, we want you to like implement it into Jenkins or put it in your build phase, and by the way, we want to train you on the product, here's the results, here's where it's going to come into your Jira, or here's where it's going to come in as a report and email, and it takes a long time to do this, just not scalable in any form or fashion. We were stuck to a specific vendor. So actually for you guys, this is probably very relevant, but for us, like, we were Fortify, right? So we had to go to every single dev team, and once a dev team says, yay, I implement it in Fortify, I go to the next team, I implement Fortify. Hey, what happens if we change vendors? Oh, you gotta be kidding me. I gotta go back over here, I gotta change it on this dev team, I go back over here, I gotta change it on this dev team. We needed multiple connection points for various tools. So for example, we're not just doing code risk analysis like Fortify, we're also looking at open source compliance licensing. So things like Black Duck, White Source, or FOSSA, which also need the code to say, hey, are we compliant and open source? We've also got custom checks for things like, which by the way, I heard Aaron mention up on stage prior, things like you guys embedding tokens and hidden secrets in your code repos when you upload them to your GitHub, which, guys, don't do that. But don't do that. But it's a problem, right? How do we check for these things and be able to identify? We have our own custom ways of doing this. So essentially, we kind of had all these various points with no central metrics of what's going on. So we said, okay, there's a way for us to be able to build a solution. What we really needed was something that sort of did code quality orchestration. So something that said there's a single pipeline at which developers can register themselves, self-register if they want through an API, provide all the components they need. We would have all the technology in the back end to do everything that we needed to do, and we would have no human interaction, which, by the way, was super important, because as you guys know, you're developers, we don't like human interaction. So if you can make it non-human interaction, I'm on board. So I'm going to give you sort of our architecture of the product that we kind of built. And you kind of look at this sort of from the top down, right? But essentially, we wrote this API, completely Swagger, fully documented, all API REST. We have a website, you go and you register, you sign up with your API call, you provide us your information. We have pre-processing modules. So for example, we have every language imaginable. Not all tools support all languages. So for example, if you upload some weird language that we don't have the thing, we'll kick it back in an API call and say, hey, by the way, we don't support that language, I'm sorry, you're just gonna have to wait, is essentially what it comes down to. But we have all of these things that normally you would figure out in meetings, we automated. On post-processing, we would eliminate false positives. We would consolidate things. We know your project uses this framework, which, by the way, raises 15 issues that aren't important to your project. They get eliminated before they get sent out an API call back to you. All of these things then all consolidate on the back end where we get all the metrics and visibility. We can look at an app and we can see how things are going through trend. And so it ended up going to this. So this is sort of an example of the product that we built. What was really interesting is we started this project at the beginning of this year. We had in February or so maybe 2 of our app teams. We picked 2 app teams that were primary who wanted to join in this program, and they enrolled, and we worked with them. And then everything else is self-registered. We have no stick, no policy. And then by the end of this month, we had 846 applications enrolled. They are growing daily through word of mouth, through people just saying, hey, how do I find flaws in code? We just paste the URL, they go there, it's got the API documentation, they're like, oh, here's a client if you want to use it, they can enroll it, boom, they're done, and that's it. And every time they go through their process, it's build. We don't change your process, we don't change our pipeline. This has been hugely successful, way more than we could have even predicted. And what's great for the security team is we can swap out or add newer capabilities in the back end, and it doesn't change for engineering at all. Let's say you want to move from one CI/CD pipeline to another, it doesn't matter to us. You do whatever you want. As long as the API gets called, it makes no difference to us. We'll keep improving our results on the back end, and nothing ever changes. And so this has been hugely successful for us. And we've identified that developers and engineers that we're calling and talking are like, one, this is great, you're working with us, you're putting it in a format that we can understand, and this is something that's been very successful. And by the way, thanks for eliminating all of the false positives, because they only get very centered policies on things that are really relevant to them. And so this has been sort of how we at Capital One manage some of that process in order to make it work. All right, so I don't know, how much time do I have? I think I have like 20 minutes, so I think we're right on time. All right, so I've kind of walked you through a little bit about, on security side, some of the things that we need to do to improve the relationship. Also, some of the ways at which in Capital One, we built technology to actually help improve some of the relationship. But you as engineers, guys, by the way, are also a part of this. So here's the things that I need you guys to do. So first of all, here's sort of the things that I sort of just walked you through, which is make it as simple as possible, ensure results are high quality. This is sort of our job, right, in order to do that. But your job, security is also your job. And the thing about it is you can't point at security and say, well, security, that's what you need to handle and that's your responsibility. It's also for you. Quality is not just about making it function and making it perform. It needs to be secure. So just like 3 legs of a stool, right? It needs to function. It needs to do its job, which is basically like it's got to stand there and do it. It's got to be able to perform. If I put weight on the thing, it's got to work. But that thing, if it's unstable and it's not secure in its thing, it's gonna collapse. Security is part of that. Look at Equifax. I just love to point it out because it's the top of the news, right? We've got great quality code that did its job, but if it wasn't secure, then do people consider it quality, right? And that is something that I think you guys as engineers really need to think about. And that should be part of your mantra on anything that you do and you build. And by the way, security becomes even more critical in your job because today, I mean, basically, I would say, no, not today. In the past, this is basically what you dealt with, right? What we've talked about mostly in applications and development teams is you guys are coding and developing applications. And there's the rest of this stack that's sort of below you. But in actuality, today, this is what it looks like, right? You guys as developers, as engineers, with Rise of DevOps, with what you're doing, code is not just running applications. Code is configuring in real time and managing everything from OS to drivers to storage to networking. What you write in your code is starting to be consolidated. When you look at forward-thinking companies, most of this is all run through code. So when you start thinking about security, security starts relying almost exclusively on you as engineers and as developers because you're the ones who are now starting to run all of this. And how you configure it, how you manage it, what changes are made are all now done in code. This becomes really critical for you guys as a team. Here's 3 things I'm going to ask you guys to do. So the first, build code like everyone sees it. This is sort of an amazing thing. This chart that you see right here is an example topic of where they took a product that was internally developed that they opened and pushed open source. And the metrics that you see here are the blue line is the number of lines of code that have been added, or the number of new problems or alerts in security that were created, and the orange line is the number of lines of code added. You'll notice that dividing line right there in the middle, that's when they went open source. That's when they pushed out into the public repo. You see all the prep work that was done. All these new issues were being found all prior to them pushing because they wanted to make sure, developers wanted to make sure their code was clean, right? That it looked good. You guys know the pressure. When you're writing and someone else views it, you can't have messy code. It doesn't work, right? You're going to get a lot of crap for that. And so you see the number of issues rise, but then as an open source, you see the maintenance and actually as the issues drop down. It's amazing just the concept of understanding if someone's looking at my code, what do I think and what's the peer pressure of that? To see the amount of security issues drop is pretty fascinating. So here's the thing for you guys. I don't know if you have a way at which you peer review code. I'm not sure if you have an open way of which everyone inside your company can look at each other's code, but you absolutely should because it is really important and it changes your mindset and how you build things. Second, you guys need to have the hacker mindset. This is something that, I know it's difficult because there's sort of the builder mindset and the breaker mindset, and these can two be completely different. But ultimately, you guys as software developers, you have the advantage over security people. Because security people are like us, we're not engineers. We know the security part, but you guys know the building part, and you can easily learn and understand the breaking part. Just like that code example. If I ask you to put on that hat, you will intricately go through and you can find all the different ways of breaking that software, of finding the flaws in the software and thinking like a hacker way faster and probably way better than security people do. And that's something that you guys need time for. So is there anyone in here who is like VP of engineering or director of engineering in some of these? Okay, guys, my ask of you is you've got to give your team time to do that. So as you build out roadmap, as you do these types of things, functionality is important. But look at, actually, if you just gave these guys a week to sit there and say, hey, let's do a couple whiteboarding sessions, put on a hacker mindset and look at how people can break, you'd be amazed at one, how much fun it is, and two, the amount of great things that come out of that. It's amazing some of the stuff that comes out. You can see some pretty cool stuff in there. So have that mindset, and I hope the guys who are your bosses give you the time to have that mindset, which is really important to do, because I know you guys, once you do it, you have a lot of fun. And finally, third, I want you guys to stand up and lead. And so here's what I mean by that. You saw the amount of security people that are in the company. There's like 6, 7. Well, there's probably more than not here. But the thing is that they're struggling to build a relationship with you guys, right? And one of the things that you guys can do, especially senior engineers or senior developers, you guys know security. Stand up and go to these guys and be a champion for them and say, hey, listen, if you want something from our team, like a security issue or knowing about patching a bug or something, I'll be your guy. Like, I'll be the representative. Go to them and say, I want to help you out. It does a couple things for you. One, it shows leadership to the rest of the team that, hey, security is important. But two, it allows you to expand your capabilities across outside of your org and just your team, which is an absolute sign of leadership that helps them and says, hey, I will stand up, I'll be responsible, I'll help you manage security in our development group. If you need me, I'm the one that can help do that. Make that part of that team, because that's the only way these guys are going to be able to accomplish anything. It really is. They don't have the resources, time, or knowledge set that you guys do to help build this and make it happen. And if that's not enough to convince you, finally, it's great for your career. I got to tell you, how many, security is in the news every single day. Every single event, every single thing popping up, security from Trump to anything, it's all about security, InfoSec, and cyber. And at the end of the day, the quality of engineer that you are will be determined on also whether you have security knowledge. Because guys, this isn't a choice anymore, right? Security used to be optional. It's not. When you look at Apple, Google, all of these guys, security becomes fundamental core to what they do. You guys are seeing a presentation, which I'm going to see from Aaron, I think, on blockchain, right? Cryptocurrencies. That is a fundamental, security is a feature and a part of that. People, developers, security is core of what you do. And the guys who know security and know development, as you can see here, are fundamentally getting paid a lot more money. And because their quality of their engineering has gone up. Security is a career path too, right? It's something that, as you can see, is not going anywhere and is doing nothing but growing at exponential speeds. So if the security team offers you classes, if you have the ability to take classes, this just makes you a better engineer. It makes you a better developer. It makes you more unique in the marketplace that there is today. Especially as you see everyone's turning into engineers, right? A lot of people are coming into this boat. How do you step out and become more senior and more thoughtful? Understand security, because it's going to be everything, right? And so, finally on my last slide, it's fitting that I ended at this. This is how it might end up. But understand, before I show this to you, this is purely a joke, and I don't really believe this, but I think it's funny enough. This is the end of the cartoon.
You and me is pals, ain't we, Chester? Huh, Chester? Yeah, Chester. Hey, you want us to pick up some bones for you? Huh, Chester? Huh, Chess? Huh? Chester's my hero.
Okay, so that was sort of my funny end joke. All right, so that's it, pretty much. Thank you very much, guys. Hope you enjoyed it.